Now, there are times that you will want to implement a superclass that keeps the details of implementation to itself. That is, your superclass wants to keep its data members private. Now, when a superclass puts its data members private, it means it will provide no way for a subclass to access that data directly, like we saw in the previous classes, or maybe initialize variables on its own. Now, you need to understand that encapsulation is actually a primary attribute of object-oriented programming. And that's the reason Java provides a solution to this particular problem. Because if you have a superclass that has private members, and then the subclass cannot access those members or initialize data of its own, then that is a problem. And Java provides a solution to that particular problem. So a subclass is going to use the keyword super whenever it wants to refer to its immediate superclass. If the subclass wants to refer to its immediate superclass, it's going to use the keyword super. Now, super has two general forms. The first one, or maybe general uses, the first one is we can use super to call the superclass constructor. Number two, we can use super to access a member of the superclass that has actually been hidden by a member of a subclass. So let's examine, or let's look at the first use of super, which is to call superclass constructors. Let's look at the first use of super, which is basically to call superclass constructors. Okay, I want us to actually complete the implementation of the box weight using super. I want us to complete the implementation of the box weight using super. So we have our class box here, the class box that you see here. Now we want to have this superclass. We want its variables to be generally private, so that we can bring the concept at home. We want it to be generally private. We want it to be generally private. So let's make these variables private. So private double width, then private double height, then private double depth. So they are now private. That means its subclasses are not able to really access them directly. So from there, I want us to move to creating the constructor clone of an object. Of course, we already have it here. We are going to leave all this the way it is. Then we move to the constructor that is used when all dimensions are specified. We don't have that. Let's add it here. So we can add it here. So let's say constructor used when all dimensions are specified. Constructor used when all the dimensions are specified. So let's create the box constructor for when we have all the dimensions. So we have double W, we have double H, we have double let's have double D, yeah, double D. And then here we're gonna have width equals to W. We're gonna have height equals to H. We're gonna have depth equals to D. We're gonna have depth equaling D. Now from there, let's look at the constructor that we can use when no dimensions are specified. This constructor is going to remain the same, just the way it is. Then we have the constructor when a cube is created. We are going to also to leave it the same. Then we are going to compute and return the volume. This method is going to be the same again. So the part that I want us to make changes is we change the box weight subclass to actually implement all the constructors. The box weight subclass, this one, should implement all the constructors. So say let's say in this comment, let's say box weight fully implementing all constructors, all the constructors that we have actually put down in this superclass. So we want this this subclass to be able to implement all those constructors. So the first thing is now we have the class box weight extends box that we are now using to inherit. So from here we need to create the construct to construct a clone object. Let me allow me to remove this. Allow me to remove this. So we need to construct. Is there anything I removed that I shouldn't have removed? Okay, so allow me to put the clone object. Let me just put it up here. I don't want to mess up with anything. This code is going to take us time to check out where the issue is. So I'm going to say construct a clone of an object, and as we've done previously, you see we need to have box weight, and then what we are really supplying to this box weight is box weight, the object of box weight. So box weight ob is what we are supplying to it. And then what we are going to have here, we are going to use the keyword super. We're going to use the keyword super, and the keyword super is going to take in the object. The keyword super is going to take in the object, and then weight now here is going to be obtained by getting the object weight. So ob dot weight is going to obtained by getting the object weight. So ob dot weight. Now you need to have to implement a constructor when all the parameters are specified. Let's say constructor when all parameters are specified. Constructor when all the parameters are specified. So we have box weight double w double h double m. Here let's do this. Just do this specification afresh in these parameters. So what we are going to have in this parameter list is double w. You're gonna have double h. Okay, we're gonna have double m, double w, double h, double m. The reason as to why we have double w, double h, and double, actually not double m, let's have double d as well. Let's have double d as well, and then let's have double m. Then we are going to use super to actually call the superclass constructor. We're going to use super to call the superclass constructor. So we're going to say super, and what we supply to super, because the superclass box has width, it has the height, and it has the depth. So we're going to supply the 3, because that superclass has the 3 dimensions. Now here we are calling superclass, the superclass constructor. Here we are calling the superclass constructor, and then we assign weight because weight is actually an element of the subclass box weight, so we're going to assign it there. So we have implemented a constructor when all the parameters are specified. We still need to have a default constructor. So default constructor for this class. Now the default constructor is going to be box weight default parameter lists, and then here we just have super, and we don't specify anything inside super because it's a default constructor, and the weight is, we assign it to -1, where we said when we assign -1 it simply means an undefined weight that is actually undefined. So now we again need to have a constructor when we define a cube. Constructor when a cube is created. When we create a cube, we need to have a constructor. Now the box weight, this constructor must take two parameters. The first one is actually the length, and the second one is the weight. So we have double, let's say double len, comma double m. We have used m for the weight, so that is what this constructor is going to have. That is what this constructor is going to have. Then we are going to call the constructor against super len, and then we will assign weight to m. We'll assign we'll assign m to weight. Yeah, so we have all the constructors that are actually implementing this particular class. Now let's come to our main. I just want to remove everything in this main class. Let me just remove everything, and then I want us to create box 1. Say box weight, my box 1 is equal to new box weight, and I want to create 3 boxes. So to save on time, I'm going to copy this line just to make a few changes. I'm gonna copy it. Now I'm gonna paste it twice down here. I'm gonna paste it twice. So the second one will be my box 2. This one will be my box 2. This other one will be my box 3. So the first one, we are going to give it the values, just random values, which is 10, 20, 15. We give it something like 32.1 for the weight. Now the second one, we give it random values 2, 5, 8. We give it maybe 12.6 for the weight. And then this third one, we won't give it anything because we want it to be constructed using the default constructor. So let me just put a comment there and say default. You want it to be constructed using the default constructor. Then I'm going to create my a cube. So box weight is one word. Box weight, my cube, is equal to new box weight, and because now this one is a cube, we want to give it 2 measurements. The first one is the length and the second one is the weight. So let's give it maybe a length of 23 and a weight of 7.8. weight of 7.8. Again, we remember we have a clone, so let's create another object, box weight, my clone, box weight my clone. We say is equal to new box weight is equal to new box weight, and what we are supplying here is we are actually creating a clone of box 1. So let's supply my box 1 in there. Let's apply my box 1, yeah, in there. Then now let's declare our volume. So double vol. After declaring our volume, what I want us to do is I want us to get the volume for my box 1, and then we print it. The volume for my box 2, then we print it. Yeah, so vol is equal to my box 1 dot volume, my box 1 dot volume. So we can print this. We say system dot out dot print ln, and what we are printing here is simply the volume. You can get the volume for box 2, vol equal to my box 2 dot volume, and we can also print this and say system dot out dot print dot print ln, and what we are printing again is vol. And let's also get the volume for my box 3. So my box 3 dot volume, my box 3 dot volume, we say vol is equal to my box 3 dot volume, so that we can print volume. Okay, so we again say down here that system dot out dot print ln, what we are printing here is again vol. You can print the weight also for the specific boxes if you want. You can also print the box of a cube, the volume of a cube. Now if we run this program, let's come here and run this program. Just run it. Let's come here, you check the output, 3080 -1. What I want you to do is I want you to pay attention to the constructor that is actually constructing a clone of an object. Let's come to this constructor, the one that is this one here, the one that is constructing a clone of an object. This is where I want you to pay your attention to. I want you to notice that the super method here is passed on an object of the type box weight and not an object of the type box. You can see ob there. We have said box weight ob. So this is an object of the type box weight, and it's not an object of the type box. But remember that box weight is also a what? Box weight is actually a subset of box. You need to put that in mind as well. You need to put that in mind as well. So this will basically this will still also invoke the constructor, the box constructor. So this will still invoke the box ob. Now, so when a subclass calls a super that is the super method, it is actually calling the constructor of its immediate superclass. So here, when we are calling this super method here, as you can see, then we are calling this is a subclass, box weight is a subclass. Calling the super method here is actually calling the constructor of its immediate superclass, and the immediate superclass for box weight is box. That's very important for us to really grasp and to really understand, for us to be able to really digest this content. So that is the first use of super. Now let's look at the second use of super. In the second use of super, super is actually like acting like this keyword, the difference is that it always refers to the superclass of the subclass in which it is actually used, and the general form for that is you have the super, then dot the member, or rather the method, or maybe the instance variables that follows. So in most suitable, it is actually most suitable in situations in which we have member names of the subclass that hide members by the same name in the superclass. So we can understand this better by looking at an example. Let's look at an example. Allow me delete this. I don't want to have any conflict right now. I don't remember what class names I have used, and that might bring conflicts in my package. Don't want that to happen. That is why I am deleting these stuffs. So that's why I'm deleting these stuffs. So in my lessons package, I'm going to right click and create a new class. I'm going to right click and create a new class, and I'm going to call this class, I'm just going to give it the name users of super. Users super. Just want to demonstrate how a super is actually, how the super is used to refer to the superclass of the subclass which is used, and in the situations where the member names of a subclass are hiding the members of the superclass by using the same name. That is something I just want to demonstrate. So below the lessons package here, I'm going to create a class, and let me put a comment and say using super to overcome data hiding. Remember that if a subclass has data with the same names, we covered this, we said that with the same names as data in the superclass, then that data in the subclass overrides or hides the data in the superclass. So we want to actually avoid that by using the super keyword. Now, so let's create a class A. We are creating a class A. Now A is actually our super. I'll just say int I. We are giving it the variable I. Then let's create a subclass B. So we are extending A. So B, class B extends A. Class B extends A. And for this particular class, we want to also give it int I. So pay attention, we have int I in the superclass A, and we have int I in the subclass B. So it means the I in the subclass B actually hides the I in A. It is actually hiding the I in A. It's important to make sure you have that concept. Now let's create let's create a constructor. Let's say B. Let's create a constructor. We say B. Let's give it int A, comma int B. Give it 2 parameters, and then let's say, so if we say super dot I want you to see something. When you say super dot I is equal to A, I am saying super dot I is equal to A. Because I have used the word super and I have said super dot I, it simply means I am referring to the I that is in A. So refers to I in A. I'm referring the I that is in the class A because I've used super dot I. So when I say here I, I say I is equal to B, now the story changes. When I say I is equal to B, I am simply referring to the I that is in B. When I don't use super, I am referring to the I that is actually in the subclass. So this one I is referring to I in B. So let's end it there. Now let's have rather a method. Let's have a method and say that is going to show, let's say void show. Okay, a method that is going to show those values. Void show is the method in this case, and this method I want it to show us the value of I in the superclass and the value of I in the subclass. So it's going to say system.out.println, and this one is going to say let's just say I in superclass, and then to access I in superclass we have to say super.I. so we need to put a plus here and to say super.I. Then let's also try to access the I in the subclass. So system.out.println, we are accessing the I in the subclass. I in subclass. Now to access I in subclass, we simply have to say plus I, and that's it, without using the keyword super. So in our main class here, let's add the main first. So say public static void main, and we have string args, we have square brackets, and then we have opening the curly braces. We are opening the curly braces. Now let's create a sub object that is actually an instance of the class B. So B, we say sub ob is equal to new B. Sub ob is equal to new B, definitely. Why? Then we give it 1, 2, 1, 2. Okay, then let's call the show method on the sub ob. So we're just going to say sub ob dot show, so that it can show us those values, so let's run this program. Let's see. So when we run this program, the output is I in superclass is 1, I in subclass is 2. As you can see here, sub ob is equal to new B, we have supplied 1, 2. Now the reason it's doing that is because here we said super.I, so it's making a reference to the superclass, and then here we said here we said I is equal to B. Okay, so the variable I in B here, as I have said, I'm just repeating this, the variable I in B is actually hiding the I in A. But now here the super here in super.I actually allows access to the I that is defined in the superclass. So super can also be used to call methods that are hidden by a subclass. It's not only used to access variables, it can also be used to call methods that are hidden by a subclass. So I'll stop there for this.